Welcome to the second video lesson from the Graphing and Transformations unit. And for this video lesson, I'll be talking about reflecting functions. So let's take a look. So what is a reflection? So when we're flipping an object over an axis, that is considered a reflection in Math 12. So when we're dealing with reflections, we will have no rotations, no translations, and we will not have a change in size. Now for Math 12, we have three types of reflections. We have a vertical reflection, we have a horizontal reflection, and we also have an inverse reflection. Now when we're dealing with a vertical reflection, this means that things will be reflected over the x-axis. So as you can see in my diagram right here, this red line, this is the x-axis, and this will act as a mirror line. So if I have an object located right here, and if I want to reflect this object across the x-axis, then I might have something like this. So this is an example of a reflection in the x-axis, and this is also called a vertical reflection because we went from the top to the bottom. Now one more thing that you might notice is that if you look at one point from the original function, you'll notice at this point here highlighted in this yellow circle here, you'll notice that the x-coordinate is negative and the y-coordinate is positive. If I take this point and if I reflect it, I end up over here. Notice that the x-coordinate is the same, but the y-coordinate is different. So over here the y-coordinate was positive, but over here the y-coordinate is now negative, but the x-coordinate is actually still the same. Alright, so that's one property of a vertical reflection. Moving on to a horizontal reflection, this happens when we're reflecting objects over the y-axis. So once again, this line highlighted in red, this represents the y-axis. And let's say I have an object here on the left-hand side, and if I want to reflect this over the y-axis, it might appear somewhere over here. And notice that this object went from the left-hand side to the right-hand side, so that's why it's called a horizontal reflection. And the line, the y-axis right here, once again, this is acting as a mirror line. Now one more thing that you may notice about a horizontal reflection is that if I consider this point right here, once this point is reflected, it ends up over there. And you'll notice that these 2 points have the same y height. So maybe the y height is around here about 1 to about 3, about 2.5. So the y coordinate is the same, however the x coordinate is different because the x coordinate over here is negative, but once you reflect it across the y-axis, you get a positive x coordinate. So for a horizontal reflection, the y coordinate stays the same, but the x coordinate will change. And finally, let's take a look at an inverse reflection. For an inverse reflection, this happens when you are reflecting objects across the line y equals to x. So here's my line y equals to x. So this right here is now my mirror line. So if I have an object over here, and if I reflect this across the line y equals to x, my new object may appear like this. And for inverse reflections, the key thing here is if you have a coordinate, or if you have a point on the original function, for example right here, all you have to do is to get the reflected point, you just switch the x and y coordinates. So once this point is reflected, it will end up over here. So if you consider the x and y coordinates right here, you have a negative x coordinate and a positive y value. So perhaps this is going to be -1, 2. So this point is -1, 2. And all you have to do is interchange x and y in order to get this point right here. So this point right here is going to be the point 2, -1. And that's basically when you just switch the x and y values from this point, and then you'll get that point right there. All right, let's move on. Let's take a look at horizontal reflections now. I'll use the letters HR to represent horizontal reflections. So a horizontal reflection will occur when the x variable is replaced with a negative sign in front. All right, so here's my x variable. So if my x variable is changing from x to negative x, for example, then that would represent a horizontal reflection. The x-coordinate will change sign, but the y-coordinate will not change at all. Okay, so let's take a look here. I have this function y equals to the square root of x, and then I'm going to change that to y equals to the square root of negative x. So let's graph both of these functions and let's analyze them. So here is my x variable, highlighted there in red. And here's my new function after it's been transformed. I have negative x. And now let's graph y equals the square root of x using a table of values here. So here are some random numbers for my x values. So 0, 1, 4, 9, 16. These are my independent variables or independent values. And let's get the corresponding y values now. Alright, so when x is 0, then y will be 0, and basically I'm just taking this the 0 value and I'm just inserting it right back in there, so the square root of 0 will be 0. If I have 4, the square root of 4 is 2, so that's how I get my corresponding y values. And here's my graph. This is the graph of y equals to the square root of x. Alright, now let's graph y equals to the square root of negative x. So here we are, y equals to the square root of negative x, and here's my table of values. Let's pick some random x values, and here are my corresponding y values. Alright, so y equals to the square root of negative x. That graph is highlighted here in blue. And before I compare the red graph and the blue graph, you might notice that, hey, the y values here are exactly the same as the y values over here. The only difference is that if my x value here is positive, then my corresponding function will have a negative x value over here. So, and that kind of makes sense. You have a negative sign here, so all these x values should now be negative. Alright, so if I look at this function here in red and this function here in blue, it looks like the red function right here, if I highlight this now in blue, it's been kind of reflected horizontally. It moved from the right hand side and now it's being reflected towards the left hand side. Alright, so that is an example of a horizontal reflection. So once again, for a horizontal reflection, your x variables will change from x to negative x, and that would mean all your x values will now be negative, but your y values are still the same. Vertical reflections. So a vertical reflection will occur when the y variable is replaced with a negative sign in front. So let's take a look at that. Only the y coordinates will change sign, but the x coordinate will not change at all. Alright, so if I have my variable y, and if y goes from y to negative y, then that is an example of a vertical reflection. So here's an example here, y equals to x squared. And then I have negative y equals to x squared. So this is my original function, y equals to x squared, and then my function goes through transformation, and then I get negative y equals to x squared. So you'll notice that y went from positive to negative, so that is an example of a vertical reflection. Now, one problem is that a lot of times in mathematics, you usually won't see your equation written like this. All right, so you may have to isolate the y variable, so get the y variable by itself. And once you isolate the y variable, you would get y equals to negative x squared. So I'm just dividing both sides of the equation here by the negative sign, and so then I'll have y equals to negative x squared. And this line right here and this line right here, so this line and that line, they look different, but they are indeed equivalent. They're the same. All right, so now let's graph these two functions and let's analyze them. Graphing y equals to x squared. Here's a simple table of values. Here are my corresponding y values. And once I graph everything here, I should get a parabola that's opening up. My domain here is all real numbers, and my range is y is greater or equal to 0. All right, so now let's graph y equals to negative x squared. Here's a table of values. Here are some random numbers. Actually, these numbers right here, I'll use the exact same numbers here for x. And let's see what we get for our corresponding y values. All right, so if I insert these x values, my corresponding y values will be 0, negative 1, negative 4, negative 9, negative 1. And here's my corresponding graph, a parabola highlighted in blue, and it opens down. Now, if you compare the table of values, you'll notice that the x values are the same, but the y values are different. So these y values are positive, and the y values over here are negative. And that's because you changed y to negative y, so all your corresponding y values should indeed be negative. So the red graph here, it looks like it's been reflected across the x-axis, which is a vertical reflection, and then just kind of appears just below the x-axis. So if I highlight this graph right here, it's just been reflected across the x-axis, which represents a vertical reflection. All right, so what's the difference between a horizontal reflection and a vertical reflection? Well, for a horizontal reflection, the negative sign will be inside the function. For a vertical reflection, the negative sign will be outside the function. So here's an example of a horizontal reflection. Notice that the negative side is inside the two brackets right here. So this represents a horizontal reflection. So the negative sign is inside the function. So this is a horizontal reflection. Now, if I consider the same absolute value sign, if the negative sign is outside, this function right here, then this would be a vertical reflection because the negative sign is outside the function. Let's take a look at a few more examples here. I have y equals to the square root of x, and after a transformation, I have a negative sign right there, and I also have a negative sign inside the bracket. So the negative sign is inside and outside the function, so this would represent both a vertical reflection and a horizontal reflection. And for my last example here, y equals to 1 over x. Once it undergoes a transformation, then I have y equals to negative 1 over x. Now, when you have an expression like this, this could be written in a few different ways. So for example, it could be written as y equals to negative 1 over x. And it could also be written as y equals to these brackets, 1 divided by negative x. So this expression right here, the original transformation, and this expression here and that expression right here, they're actually all the same. So for this example, it could be either a vertical reflection or a horizontal reflection. All right, let's talk about inverse reflections now. And this is very similar to what you learned in grade 11 math. So whenever you have a function y equals to f of x, and if you see this notation f to the power of minus 1 of x, this means the function has undergone an inverse reflection, or an inverse transformation, sorry. So this is the notation that we use to represent inverses. So an inverse reflection is simply a reflection over the line y equals to x. And an inverse reflection happens when the x variable and y variable switch their positions. So then you kind of isolate the y variable. So here's y equals to f of x. If I interchange y and x, I should get something like this. X equals to f of y. So this is representing that we're doing, basically this means that we're undergoing an inverse situation here. Now let's take a look at an algebraic example here. Given the function f of x, find the inverse. Y equals to f of x equals to 3x minus 5. So sometimes you'll see f of x equals to 3x minus 5, but f of x is the same thing as y. So this equation right here can be written as y equals 3x minus 5. So if I want to find the inverse of this linear function here, the first thing I have to do is I need to switch the x and y variables. So here's x equals to 3y minus 5. Originally, here's my y, and I'm just going to change that with x. Here's my x originally, and I'm going to change that x with y. Once you've changed x and the y variables, then all you have to do is isolate for the y variable. So here's my y variable, and I just need to isolate for my y variable, so I need to move this negative 5. And if I do that, I get x plus 5 equals to 3y. I'm just going to move the 5 to the other side, so the negative becomes positive. And then I have a 3y here, so I divide both sides of the equation by 3. and I get x plus 5 divided by 3 equals to y. So this is my inverse function. And if you want, you can also change this y to f to the power minus 1 of x. So this means that this is an inverse function. All right, let's move on. Some reminders of an inverse function. Since the x and y variables are changing, the domain and range will also change. So if you are given the function y equals to f of x, and if you want to compare that with the inverse, y equals to f of to the power of minus 1 of x, the domain and range for the original function will actually switch positions when you're talking about the inverse. So the domain here will be the range over here, and the range over here from the original function will be the domain for its inverse function. So if my domain in my original function is all real numbers, for example, then for my range, for my inverse function, the range will be all real numbers. Now, when you're graphing the inverse function, take several points on the original function, switch the x with the y coordinates. So for example, if you have 5, -3 on your original function, then all you want to do is just simply change those two coordinates, and you'll get the point -3, 5. The new points, for example, -3, 5, they can be used to generate the graph of the inverse function. So you will definitely practice this a lot in the homework. All right, a little summary here before we get on to a few practice problems. If I have y equals to f of x being transformed into y equals to f of negative x, then this represents a horizontal reflection. And for horizontal reflections, we are reflecting over the y-axis. If I have y equals to f of x, and if it undergoes a transformation and looks like negative y equals to f of x, here's a minus sign, this represents a vertical reflection over the x-axis. Now, once again, a lot of times you may not see the function written like this. Sometimes the function will isolate for y, so this negative sign will indeed be over here. So you have to be comfortable with noticing vertical reflections when the equation is written in this format, as well as this format below. But both of these equations are equivalent. All right, and then finally, let's look at the inverse function one more time, y equals to f of x. And if I interchange x and y, then this means this is simply an inverse reflection over the line y equals to x. All right, let's look at a few practice problems now. Indicate the type of reflection for each of the following equations. So I have 4 examples here, 1, 2, 3, and 4. For my first example, I have y equals the square root of x, and then now it's being transformed into y equals to the negative square root of x. So what kind of reflection is this? Well, this negative sign over here, since it's outside the function, so I could write this equation like this as well, negative y equals to the square root of x. And since this is on the outside, I know this will represent a vertical reflection because y is being changed from positive to negative. So this will be a vertical reflection because, once again, y is being changed from positive to negative. The next example here, y equals to the absolute value of x minus 3. I have a minus sign there on the outside, and this is very similar to the previous example. So once again, y is being changed from positive to negative. So once again, this is a vertical reflection. Let's take a look at example number 3 here. I have y equals to the absolute value of x plus 2, and then I undergo a transformation, and then I get the absolute value of negative x minus 2. Now, if you want, you can distribute this negative sign to the x and the negative 2, and you'll get negative x plus 2. And since the minus sign is inside the function, that means x is being changed from x to negative x, and that will represent a horizontal reflection. All right, let's take a look at the final example here, y equals to 3x plus 2, and then after transformation I get y equals to negative 3x plus 2. This one you got to be a little bit careful with, and you'll notice that this negative sign here, notice that the positive 2 on the left hand side, it remains positive 2. And the only thing that's being changed in this case is the x value. I go from a positive situation here to a negative situation over there. So we can actually indeed rewrite this as y equals to 3 bracket negative x close bracket plus 2. These two expressions here are equivalent. And you'll notice that x is going from positive to negative, so this will represent a horizontal reflection. Okay, so those are some 4 simple problems where we practice identifying whether we have a vertical or a horizontal reflection. Next example, given that AB is a point on y equals to f of x, find the coordinates of a point on the function y equals to negative f of negative x. Okay, so my original function is y equals to f of x, and after a transformation, my new function will be y equals to negative f of negative x. So you'll notice that I have a negative sign on the outside, so what that means is y, right here y is positive, and then y will become negative in this case. So this represents a vertical reflection. So what that means is all y values go from positive to negative. So if I have my original point AB, the y coordinate here, which is b, that will go from positive to negative, so I just insert a negative sign in front of the b. Alright, so that takes care of this this outside negative sign. And now let's look at this negative sign inside the function. So x is going from positive to negative, so that will represent a horizontal reflection, and that means I take all my x values and I just replace them with a negative sign, so I'll get negative a comma negative b. So therefore a new coordinate in the function will be negative a comma negative b. For my second example, I have x equals to negative f of y. So once again, my original function was y equals to f of x, and then I undergo a transformation, x equals to negative f of y, and I want to find the new point AB. Alright, so let's take a look at this example here. So my original function was y equals to f of x, and since there's a negative sign there, that's on the outside, so that will represent a vertical reflection. So when you have a vertical reflection, this is what you would have. And then finally, x and y, these two letters will interchange. So that means I have an inverse relationship. And then I go from, so my original function is y equals to f of x, and then I basically go through a vertical reflection. So I have a negative sign there. And then finally, I need to change x and y. So now I have x equals to negative f of y. And this expression right here matches my expression right here. So basically all I have to do now is I need to apply this vertical reflection here along with this inverse reflection, and then I should be able to get my new point. So my original point was AB, that's part of this function. And when I undergo a vertical reflection, that means the b value there should go from positive to negative. And once I have an inverse relationship, I just simply change the a and the b coordinates. So I'll get negative b comma a. Now when I solved this problem, I initially started with the vertical reflection and then I did an inverse reflection. But in fact, you can also do the inverse reflection first and then do the vertical reflection, and you'll still get the same answer. So let's take a look at that now. This is my original function, y equals to f of x. If I apply an inverse reflection first, then I would get something like x equals to f of y. Now this looks very similar to this, and I just need to have this negative sign. That's what I'm missing. So now I need to apply a negative sign here. But if I apply the negative sign, I actually have a horizontal reflection now, because this negative sign is not touching the y, but it's actually touching the x coordinate there, so, or this x value right here, or the x variable here. So I have x equals to negative f of y. So this is matching my original function, and I just have to take note that this negative sign is actually touching the x variable and not the y variable. So here's my original point, a comma b. I go through a inverse reflection, so then I just interchange b and a to get b comma a. And then I apply the horizontal reflection, so this negative sign is touching the x, so I need to have a negative sign in front of the b. So I get negative b comma a. So from that example, I just want to illustrate that it doesn't matter whether you start with the vertical reflection first. You could do the inverse reflection first and then the other reflection, and you'll still get the same answer, negative b comma a. All right, let's move on to the final example here. Given the graph of y equals to f of x, draw the graph of each of the following equations. Well, actually for this question, I just have one equation here, y equals to negative f of negative x. So if this is my original function, y equals to f of x, which represents this red graph right here, basically what I'm being asked to do is, can I produce a new graph once these transformations have been applied? So I have a negative sign there, and I also have a negative sign touching the x variable. So I have both a horizontal and a vertical reflection. All right, so let's take a look here. Okay, so my original graph was this red guy right here. And what I'm going to do first is I'm going to apply this, this vertical reflection here. So what that means is if I have all my y coordinates, so for example, this point right here is negative 6, negative 6. If I apply this vertical reflection, this negative sign, that means all my y coordinates will change position. So this is negative 6. So once this reflects across the x-axis here, it will go from negative 6 to positive 6. And since I have a positive 6 here, and once it's been vertically reflected from top to bottom, it changes from 6 to negative 6. This point right here, 4 comma 6, once it's been reflected, it goes from the top end to the bottom end here. And all these heights right here, the positive 2, they now become negative 2, which is highlighted right there. This is negative 2 right there. So the green graph right here represents a transformation when the graph has been reflected through the x-axis, and that is called a vertical reflection. So once I apply this transformation here, this negative value, I get the green graph. Okay. And now what I want to do next is I want to apply this transformation, this negative x here. So let's take a look at what the graph will look like after I apply that transformation. So that's my new graph after it's been reflected in the x-axis. And my other graph will now look like this. So once I apply this horizontal reflection, that would mean I take all my points on my green graph and I reflect those points through the y-axis. And when you're reflecting across the y-axis, your y values, for example, they will stay the same. Like, so the y value here is 6. And once this point is reflected across the y-axis, it's over here. Notice that this has a y value of 6. And this point here has a y value of 6. So the y value hasn't changed. But if you look at this point right here, the x coordinate is negative 6. And once you reflect that across the y-axis, it now becomes positive 6. So basically, all your x values have changed signs. So if this is negative 4, it will become positive 4. If this point right here on the green graph is negative 2, then its new coordinate will be at the positive 2 value right there. And this region right here, this has a x value of positive 6 and positive 8, and once you reflect those across, you'll get x coordinates of negative 6 and negative 8, but the y value is still the same. Okay, so this is what my graph will look like after I apply this transformation and that transformation. All right, so here's my original function, and let's just write down these coordinates, all the good points. Negative 10, 0, negative 6, 6, negative 2, 6, 4, 6, 6, 2, and 10, 2. So these are all the points on my red graph. And once I apply both of these transformations, basically this would mean all my y values basically all my y values will change signs. And this would mean all my x values would also change signs. So let's take a look here. If I apply this transformation to this coordinate right here, I go from negative 6 times it by a negative sign, then I'll get positive 6. And if I take this negative 6 and multiply by this negative value there, then I'll get positive 6. If I have the point 6 comma 2 here, if I apply this transformation, this negative sign, then that means this 2 will become negative 2, and this positive 6 will become negative after I apply this transformation right here of negative, this horizontal reflection right there. All right, so that concludes this lesson. We'll see you again in the next video series.